feel free to
Yeah.
just listen in, and then we will share the notebook and the PowerPoint after. But nice to have you here. And also, don't worry about being sick, or if anyone wants to say hi or maybe do a presentation or a brief introduction, feel free to do that. But normally we wait like more or less like 3-4 minutes to wait for people to be able to join.
Mm-hmm.
So also Jacopo, if you already want to start, or maybe Gabri or Krishna. No, you're still tuned in.
Yeah.
Because you're studying, right? And your parents are living in Germany, and now you just
Yeah.
came to
Okay.
the US.
So saying to introduce myself. Okay.
Yeah, if you feel comfortable doing
Okay.
it.
Yeah. So I am Krishna. I just joined Argilla community last month. I am studying computer science and math in the US, in Texas. And my parents are in Germany. So when I joined Argilla, I was in Germany. So my first meeting with David, that time I was in Germany. But now I'm back in the US. And yeah, basically that's me.
Thanks for coming and have you here. And also working on a cool notebook using this Distilabel, right?
Yeah. And Distilabel.
Nice. For me, I like bits from, and I'm currently working at Argilla. But a while back, a friend of mine actually introduced me to the Red Cross, or the data department of the Red Cross of 510, where Jacopo is from, and currently working as a data scientist, I think, or not specifically on NLP topics, but also on, I think, geodata and other stuff. But he will probably introduce himself later. And that's actually how I came like contact with them, and also collaborated on like an initial version or outline of the current project, and ended up eventually inviting them to showcase what they were doing with NLP and with Argilla. It's really good to have everyone here. Maybe if you want to start, Jacopo, then feel free to continue with the introduction, and after that with the presentation. And the idea of today is to do like a twofold thing. Where initially, Jacopo will use Red Cross, and specifically the data department of the Red Cross called 510, do a presentation about a project that he's been working on redirecting refugee requests to the specific Red Cross departments, if I'm not mistaken. And then after that, I will give a overview of our notebook, Jupyter notebook, with a showcase on how to use Distilabel, our package, to clean existing preference data. And that's what general introduction of is going to look like. And we'll once again share everything after the presentation, and feel free to turn off your camera, or also say hi or review it via chat or ask questions. So maybe you give our introduction.
Sure. I'm Jacopo. I work with the Netherlands Red Cross. Specifically, the Red Cross is a federated entity, so every country has their own Red Cross. We are based in the Netherlands. We represent the Dutch part of the Red Cross. I work as a data scientist in the data team of the Red Cross. We go under the name of 510. Title is data scientist, but then in practice, I do a million different things, ranging from data science to data engineering to business translation to just doing whatever is needed during emergencies, especially. And today I'm going to tell you something about actually how we have been using Argilla recently, thanks to David, who introduced the tool to our team, and it was a very good fit for this case that I'm going to present you now. Share my window. You see my slides?
Yeah, we do.
Perfect. So presenting this work on behalf of my colleague Vessel, who unfortunately cannot be here today, but he was also main contributors of this work that we present today. So talking about the work that we do. First, a few words about ourselves. 510 is the name of the data and digital team of the Netherlands Red Cross, as I just said. We support the Red Cross and Red Crescent around the world. As I just said, there in every country there is one. We always work to support a local organization, the local Red Cross. So that's a bit different than other NGOs, which usually go in a country and implement programs there. We always have more the function of supporting a local organization. In our case, with digital products and data-related services. The team comes from the surface of the Earth. We are a team of data nerds. So someone came up with the idea to be called 510 from the surface of the Earth, 510 million square kilometers. Work in 5 thematic areas, very high level, going into details, but just for you to have an idea of more or less where we work. Anticipatory action is something that we do to provide to the Red Cross the information that they need to anticipate, let's say, to take action before a disaster comes in order to mitigate the impact of a disaster. And this comes with, of course, about the magnitude of the disaster, the impact of the disaster, but also organizing the actions that the Red Cross can take to mitigate the impact of a disaster. Forecasting to more practical stuff, I would say. We work in cash and voucher assistance, so that's about distributing cash to people digitally, in our case. Community engagement and accountability, that's about communication. The project that I'm talking about today falls under this thematic area. We support emergencies of the Red Cross around the world, and that means anything that people need. And finally, we have a new, I would say, research line in water and landscape, so especially about climate change adaptation, nature-based solutions, so everything that we can do to end water where we don't have enough, and to the landscape from deforestation or desertification. Now, let's jump into the topic of today. We are talking about the Ukraine crisis. That's where this project comes from. As you know, the conflict between Russia and Ukraine escalated significantly with the land invasion of Russia into Ukraine. 6 million people were internally displaced, so it means that they were forced to leave their home and find another one within Ukraine. An equal amount, more or less, decided to go abroad in the neighboring countries, so Poland, Slovakia, Hungary, Romania, you see from, but also elsewhere in Europe. And in total, humanitarian agencies estimated that more than 20 million people need of humanitarian assistance because of the conflict. So that's, you can imagine the scale of, it's definitely the biggest humanitarian crisis we had in Europe in the last decades. Cross movement, of course, supported the Ukrainian people in Ukraine and in the neighboring countries with a number of programs. Let's not go into the details, but the Red Cross really provides programs on all different, we call them, so health assistance, shelter, so give people a house, a home where they can stay, cash and voucher assistance, just give them financial support, education for children if needed, and WASH, which is water and sanitation. Our team is though, so again, we are supporting remotely mostly, although we also been in Ukraine, but mostly supporting remotely the operations of the Red Cross. We noticed that refugees from Ukraine, in every country where they went, started these groups on Telegram and Viber, groups. These will be public groups and public channels. I don't know if you use Telegram, but it has this feature that you can create a public group where everybody can subscribe with a URL. So contrary to WhatsApp, is not invitation only. And these public groups, these public groups in different countries, and the purpose of these groups is really to share useful information for other Ukrainians in that country, how things, a number of things. Groups are used to ask for help. So for people to ask support on specific things, but also to share useful information. For instance, hey, they're looking for people, I don't know, to help out with this, or there are job opportunities in this city. I'm going back and forth from the border. Does anybody need a ride? Things like that. So really groups for people to support each other. Now, obviously, in these groups, there is plenty of information that is really useful for the Red Cross, not only to, let's say, to address the specific help request someone said in a message, but more importantly, to understand, let's say, on a bigger scale, what are the main needs of the people, and are we addressing the real issues with the programs that we run? And this is different than just passively waiting for people to tell us things on our social media channels, because sometimes people, don't even know what we can do, or they don't even think that we would help. To So in this way, really by seeing what people share among each other, we think that we can have a much better understanding of their actual problems, of the things that they actually need help with. And we use this information then to adapt program. Obviously, it's hard to analyze at scale because we're talking about thousands of messages by tens of thousands of messages by tens of thousands of people. We set up what we call a social media listening pipeline. So a pipeline to extract and analyze these messages at scale. It's the standard, I would say. About the project, I thought we were jumping into technology. The team decided to support the local Red Crosses by obviously analyzing the needs of the people as expressed in these groups, and also give recommendations how to adapt programs accordingly. We do so in 7 countries, so Ukraine and neighboring countries. For about 3 years, we started in 22, and we're going to do it as of now, it's planned until the end of 24, maybe it will be extended. And to give you an idea, we have about 4 people working on this, not full-time on the periods, but we have 2 data scientists, engineers, and 2 analysts, translators, so people that actually look at the messages and analyze them. How does the pipeline works? Well, of course, you start from Telegram, you extract, you do some cleaning of emojis and things like that. You translate them because, well, at least another Red Crosses workers, they don't speak Ukrainian. By the simplest option, that was the Azure Translator. We're based on Microsoft technology, so Azure Translator. And later, we started exploring with open source models to see if they were good enough. We were positively surprised by the quality of open source translation. So check it out. And this package NLP, which is some sort of framework to automatically pick best open source translation models in Hugging Face. In the pipeline would be to anonymize the messages. I couldn't really find a open source framework so anonymization means removing personal information from messages just for security, so names, phone numbers, and things like that. Out of the box, a package that good enough, so we put together other things in our own anonymization app, we call it, so you can check it out on GitHub. It's open source. After these first steps, we store them in a base. And everything, of course, is everything is Python-based, API Docker measure in terms of tech stack. To classify these messages, which is the first thing that you need to then make sense, and that's obviously where Argilla comes in. So these are loaded into Argilla, where our analysts them based on a labeling scheme that we defined in time with several experimentation rounds. After some first labeling is done, we can start automating the process. We use SetFit. I'm going to tell about it in a moment. You probably know it, but otherwise it's a cool framework to transformers or to train sentence, do what is called few-shot learning. So with only a few examples, you can fine-tune a sentence transformer for your classification task. You can repeat the process, validate the predictions, and then we improve the classifications as people analyze messages. I think that's the typical use case of one of the typical use cases that Argilla was made of for. The moment we use if you want to go into the specifics, we use the text classification dataset, although we're already thinking about moving to the new dataset type, the feedback dataset. Once the team, we need to have a couple of iterations with a team of analysts to be happy about the small details. But this is a screenshot of how this would look like. The different that we found out were meaningful, at least interesting for us to classify these messages. For the classification, we show both the original and message in Ukrainian and the translation, just to double check if sometimes translations might not be perfect, and we do have some people that speak Ukrainian, so sometimes we can even cross-check the translations ourselves. Just if you don't know it, as I said, it's just a framework to do few-shot learning on sentence transformers. We think it's because you don't need the prompt engineering. So I think it's more robust. You can use smaller models, so it's really fast to train and not expensive to deploy and run, because these models are fairly small, so they run on any machine. And now also there is multilingual support for sentence transformers, so you can basically do this easily on many languages. This is just for you that indeed the classification task, which was actually not that easy because our labeling scheme, I mean, we have 20 labels or so, so obviously adds to the complication, but actually with not too many examples, we get fairly good performance. So just to say that you don't need that many examples then do a decent classification. Again, it's not, we anyway have people checking the classification, so we don't need to be perfect, but it does make their job much faster. Check out sentence transformers. There are many models out there and they keep on being updated. So last mile, this is something obviously that for us, do your classification, then you need to make sure that let's say you extract from the messages the right information, and that is or effectively conveyed to the program managers of the Red Cross. And this is often the hard part. Now, we started obviously with a simple dashboard to show aggregated numbers, the most examples for each category and things like that. As you, I don't know what is your experience, but in my experience, dashboards are happy, but they're quickly forgotten. So we actually set up a process to sit down with the program managers on a regular basis and look at the data together. So for them to have the chance to really understand what we're explaining with our analysis, and help them think through how they can adapt the programs based on what we see. One of the outputs of these conversations is actually a narrative report that we produce, so that even people that cannot be in these meetings, because obviously we're all busy, especially in emergencies, can have a look at the, let's say, some high-level executive summary of the actions that we recommend to take based on what we see on these Telegram groups. These are basically the deliverables. More than even the dashboards, actually, these narrative reports is really what non-technical people like to look at, because it's just actionable bullet points on what the Red Cross can do, which is at the end the real value that you want to extract from with all this process. Figures, we analyzed many groups, more than 1.5 million, 1.5 million messages, of which we read about 10%, just to give you an idea of the effort that the analysts go through. And since the beginning of this project, obviously, things have changed a little bit in time, but we produced about 90 of these written reports, and we presented it more than 30 times in different about the next steps. Support this operation, so it's planned until the end of 24, maybe will be extended. We want to make this whole approach reusable for other NGOs, and obviously this means that we need to do some refactoring to make it more easier to redeploy and configure for a new context. On basic things like versioning, testing, and CI/CD, so that we internally can also do it more efficiently to maintain this tool. Add some user documentation. Well, I think Argilla is very user-friendly, but let's say, I think especially for the other parts of the process, we definitely need some user documentation to make sure that the thing is well explained. Thinking about when we want to use this, well, the label schema at the beginning was actually quite some try and error to understand what was the best way to classify these messages. And obviously, we're already thinking, if we want to quickly adapt something like this in a new emergency, we want to give recommendations on what the most meaningful label schema would be. And this you can do with topic modeling, things like bird topic. Get with the analysis without too much try and error, if that makes sense. That was it. I cannot give you so there is some sensitivity behind these Telegram messages, so we will not be giving a live demo of our Argilla instance, but you can code on our GitHub page. At least we put the pipeline and check out work on LinkedIn on our website.
Thank you for the presentation. And yeah, it was very interesting to hear, because it's always weird that there is always a specific person working on a specific task somewhere in the world. And for the 510 specifically, I always am amazed one of the things people are working on, and specifically in the case of data design NLP, it's really interesting to see. Audience questions, some of but let me start with questions. The Red Cross also using Argilla to annotate conversations that are happening in production.
I'm not sure if you mean with conversations in productions, but yeah, we use Argilla to annotate the messages that we get from these Telegram groups, and these are real messages continuously. Obviously, we don't do it real time, but we do it periodically. We get the messages, we classify them, and we analyze them.
Okay. Yeah, also feel free to follow up if that didn't answer your question. But yeah, I think it's like production real time just being added to Argilla and then periodically annotated. The report you generate, are they written by yourself? Do you analyze the data that's been annotated and then create these reports, or do you use like a tools for open source in the case of the privacy related stuff? But
sure. So now at the moment, these reports are prepared by hand by our analysts, and this is because there is a lot of underlying knowledge about the ongoing programs of the Red Cross and how we can adapt them. This is hard really to share in a way that would make the task possible by an LLM, in the sense to give meaningful recommendations for a Red Cross program. It's quite complex. The degrees of freedom of the problem are many. So what we can do in terms of the ground, the budgets that we have, how it is evolving across time, variables to take into account when giving recommendations about programs. So it's not just about summarizing the messages. It's a bit more complicated, and that's the part that, at least so far, we don't have attempts. They failed horribly, so we decided for now we do it manually.
Yeah, I also like the recommendation, like no prompt engineering required, as in it's quite stable in that sense, which is the nice thing I think of the predictive methods as of now. Then another one, so the use of data science, like roots, and to contribute to the Red Cross or to 510 specifically, even though you're not in the Netherlands.
We do with volunteers. Please do reach out. I will share a link in the chat in a second. If we can, so we want to volunteer with us. We'd like, of course, to ask you a couple of questions to see if there's a good fit and what we can do there. But feel free to reach out. Even I'm a volunteer with our team, so that we welcome everybody. As David did, you can bring an important contribution to what we do. So, right link.
Yeah, we will also free to take a later, but later during the conversion. So the pack mentioned for the anonymization, can you also share a link later on in the chat? And about Presidio, which is also a Microsoft tool, and you were mentioning that you were mostly relying on Azure. Did you found with that or integrate that within your pipeline, and how did it work?
Yeah, our anonymization tool is exactly a combination of Presidio, which is mostly just regular expressions for phones and things like that, emails. And we added on top some entity recognition for personal names, which is the part to get. It's not simply regular expressions. What is a name? It's highly context dependent. So we added on top some entity recognition for personal names, and we combined the two, and that's our anonymization app. Nothing crazy, but at least I find a framework that already does it.
Yeah, it was my experience with Presidio as well, that it wasn't really optimized, so to say, for at least not for every use case. And let's say for easy NMT, you mentioned it quickly. I believe there are CPP, C++ implementations, but do you run it like on GPUs, or how do you manage the scale? You just run in batch and then leave it run over the weekends and don't care about the speed, because if you're doing also annotations on top of it, can have some delay.
The second. we don't care about speed. We run it on CPU and that's it. It takes runs. We also don't have a crazy volume, so yeah, it's just fine. We don't have performance increases.
Yeah, thanks. Notation, do you also like take care of trying to find more and less representative examples in the overview?
Yeah, so indeed, so the way we do it changed over time, but we do try to select a few representative examples. This is mostly for presentation purposes. So when we then come back to the local Red Cross to give recommendations, we think it's very meaningful to show one or two very meaningful examples of this is what people are saying. I think it's a message even more than point. But in the past we did it manually, and now we are thinking about having also part of the annotation put some sort of how do you call it, link system for representativeness or how you want to how much you want this message to be visible in the final report, so to speak.
Yeah, to also give up weight or something like that to it. Yeah, it's an interesting approach, and also I think as in the LLM data sets, for example, within data paper where they kind of pre-process data in order to find the most diverse representative examples with the highest scores in the dataset. They actually also use a similar approach, but then based on embedding filters, and then based on like the similarity of text embeds and combining that with a score, they actually pick out like the most representative examples. So it might be you guys also to have a look. And then there's one final question from Marine Duri about a project like this with women. And pipeline that you described for I think the general pipeline would be very useful. So if you can share something maybe about the code, feel free to do that later, or we can add it to the Google Drive. We'll add to the presentation. And what challenges did you encounter in topics from the messages besides the anonymization part?
Yeah, say over the course of the project, the two biggest challenges were to define the label schema at the beginning of the project. There were many discussions about what make more sense. At the beginning, we simply mapped classifiers based on the different sectors. So we classified based on the ways that we already divide our work. Led to ambiguities. So then we settled on some sort of a hybrid schema, not to forget about important topics that don't fall under any specific Red Cross. So that discussion at the beginning was the label schema. It's something that you won't think. Also because the second challenge is then how to make sure that this is really actionable information for program managers, because besides, once you do this whole thing, the humanitarian impact comes if people actually take action and change programs based on the information that you provide. If that doesn't happen, it's just an academic exercise. So how then condense to actionable points, that's also something that at the beginning was not easy. We were assuming that it would be easier. And later we learned that we also need to understand quite a lot of how the programs are going in order to give good recommendations.
Normally also to ensure that you actually get like the correct annotations as well, because otherwise because I remember that we initially started off with single label classification, then decided that it would be some multi-label hierarchical approach. I'm not sure what the current approach is, but yeah, problem understanding is always too difficult. So last question, mentioned, but how do you select the Telegram groups which you'll periodically take data from? Is there like some pre-selection, or like are these like how does that work?
No, these are usually, as I mentioned, we support the local Red Cross is the local Red Cross that works with Ukrainian refugees, that knows just by asking them, because they work with these people on a daily basis. And they simply ask where do they get the information, and they tell us, they give us a list of Telegram groups that we include in our pipeline. Obviously, some of them you can simply find. So these Telegram groups, since they're public, you can even search for them on Telegram. Some of them mine because they're very popular. Others, they were just suggested by the local organization.
Okay, thank you. And yeah, there are no more questions left, but a lot of questions always mean things, I think. And to thank you for coming by, and yeah, hope to be able to you in years, and that maybe some people actually apply also based on this presentation. And yeah, I will now continue with my presentation on how to clean a preference dataset with Distilabel. So maybe what some of you might have seen is this new package that we've introduced alongside Argilla. Argilla is really focused on getting like this arbitrary data set that you would then curate and work on over time together with your domain experts and AI engineers to actually work towards a high quality data set based on your initial model predictions, based on your initial like vector embeddings or these kind of things that you actually use in order to aid labeling. And what we have recently launched is another package alongside of that, which is called Distilabel. And this Distilabel package is for creating data sets through LLMs, and mostly for LLMs, where you might use open source LLMs to initially generate some data that you might use for preference fine-tuning, and then eventually use LLMs also for labeling this data in terms of how valuable or how highly rated these 2X are going to be, where you end up with a preference data set for doing RLHF or one of these other alternatives like DPO, which is recently kind of increased in terms of popularity. And what we have been doing the last couple of months is kind of working through cleaning and getting preference data sets being used for training like state-of-the-art models. And what we've tried to do is actually use Distilabel to reduce the size and to increase the quality of the data set through reviewing both but also by human experts. And I will kind of show how you can prepare any arbitrary preference data set have clean that using Distilabel, and in this case GPT-4 Turbo as a labeler to assess preference within the screen. This notebook, and this notebook is specifically focused on the dataset Intel Orca DPO pairs that some of you might be familiar with. I will first quickly share the link with you guys so that you can actually follow along. And the DPO pairs dataset was actually being used for several kinds of models, and all of these models were performing quite well, and it's a DPO dataset. And what we've done in the end, as mentioned, is create a cleaner data set and actually fine-tune that model. And what we see with a lot of data sets that we've been using and analyzing before, like the ultra feedback data set, the Dolly data set, the Alpaca data set, is that all of these data sets, even though they are created with the right intention, sometimes there's some kind of focus on data quality that's missing, leading to subpar data sets, lower quality data sets, and therefore also eventually resulting in lower quality models and models that need to train for longer in order to generalize well to the data set, because the data set is more contains more noise and things. So the main intuition is that these cooler like closed source like GPT-4 and ChatGPT actually are more aligned with human judgment when you actually do preference labeling, and or when you need them to score the like one of the examples generated by an LLM is going to be better. And that's what we kind of use as a baseline when we are like cleaning this data set. So to get started, we actually install Distilabel along with OpenAI to make OpenAI inference calls, and Argilla in order to analyze the data later on. Then we import some libraries, sklearn to do some basic factorization, so you don't need to use sentence transformers. You can actually do that, but we'll just use IDF. Then the Distilabel library, some datasets library, and also from Google Colab user data, which basically translates to environment variables that are linked to your Google Colab, and that you can actually see here. You can kind of define them, enable them, disable them. It's a cool new feature that actually Gabri introduced me to a while ago. We'll set these environment variables, and in order to kind of and the speed of inference, we're actually going to decrease the number of examples in order to kind of see Intel DPO data set. is it normally looks like you have your system message, your question, which is going to be the instruction, and then eventually you have a chosen response and a rejected response that were already present and have been used for like several that you can actually see here within Hugging Face. And what we noticed that these models are performing well, so it's a good data set, but the data set quality can actually be better. And what we then do is load the first 50 examples. We have these the same columns as I actually saw just now. And what we will do is actually run each one of these examples through a map function where we shuffle the order of the chosen and rejected pairs, so that we actually have these generations out of which the LLM is going to choose. And we shuffle them because sometimes it was LLMs have a preference for the first over the second example. And in order to swap the chosen and rejected, we kind of want to create a random data set and ensure by doing this that we always get like a more generalized scoring method than we would do if the LLM in question that we use might have binds for the generation. Columns, because in Distilabel what we do is we work on top of a dataset, so from the Hugging Face datasets library. And we always expect that the input column for any pipeline that we use is going to be input. So we actually have this initial question column, and we rename that to input. Then the dataset kind of looks like this, where you have chosen and rejected pairs, the question input, and then we go to the create pipeline overview. So for this pipeline, we'll be using the Judge LM task, which is an implementation of the Judge LM that we've done for Distilabel. And this is basically a prompt template that you combine with GPT-4 as LLM that's going to execute this prompt. We have this LLM with the task definition, the model that we'll be using, and we'll be using multi-threading in order to kind of speed up the inference. And we'll set the max tokens to 512 just to avoid potentially generating a lot of random data that we don't need, and cranking up the costs as well. Next, we'll be defining a pipeline. This is a Distilabel pipeline. And for Distilabel, as of now, we actually have generators and labelers. And because we now just want to label the data, because we want to verify and cross-reference whether the initial chosen rejected pairs actually align with the chosen and rejected predictions from, in this case, for Turbo. And based on that, we will do a further analysis within Argilla to check if they are actually correct. And as you can see, we have a pipeline definition here. Then we would run this pipeline to create two generations, two predictions. And we would select these columns. Along with the predictions, you actually have this rationale that you end up getting, where also there's some nuance given by the to assess why it chose one output over the other. So maybe if you're analyzing your data and you're looking at it and looking into Argilla and you choose to accept one of these corrected predictions, so to say, from your LLM, you actually know why it chose that, and that you can actually kind of challenge that as a human to really align with actual human feedback and not like the synthetic generated medium quality human feedback that you get from LLMs. What we can then do is load this back into Argilla. And we have an overview of how you can deploy Argilla in the Argilla docs. But basically, what I've done now in the background is actually deploy it on Hugging Face for free using a Docker container that contains fast API, Elasticsearch, and a Vue like UI, Argilla. And we then connect with Argilla by using the URL and a generated API key. In this case, it's just owner.api key, but there's normally you can set this yourself to ensure that there's better security. Then for the dataset that we use within Distilabel, we've actually defined two Argilla functions that actually port specific task data to an Argilla format. In this case, it's a specific format that we can use to actually visualize the dataset as a Argilla dataset. In this case, you can, for example, see that it's a rating. So there's going to be two rating questions, there's going to be a rationale. So there's going to be a text question, and that's actually something that you can directly port to Argilla to directly start analyzing as a human. So within Argilla, you would then end up with a data set like this, where you have your input, your generation, and your second generation. And based on this, you can then like start with this GPT labeled data and kind of go over some of like examples that, or some of the responses that that Chat GPT or GPT-4 Turbo gave in this example. On that, what we also do is actually add some additional filters and sorting mechanisms, where you would, for example, be able to filter on shorter inputs, on longer generations, on distances for the difference of the worst and best rating. So for example, if we would go like filtering where the difference is very high, then we might like assume that in this case it's really valuable to have this example within your preference data set, and it's really easy to see that the first generation is going to be a much better than the second generation, and we can already start labeling the data. On top of that, we've also recently introduced things like bulk labeling, semantic search, and a lot of these additional features that you can actually use for quicker and more efficient labeling on top of the things that I'm showing you now. And that's also something I recommend you to play around with. The data set, what you can also do is kind of post-process the data set to cross-reference whether the initial like generation, the initial examples within the dataset were like aligned with the corrected examples according to according to GPT Turbo or any of the other labelers that you've created. What you would also be is decrease or increase the diversity and decrease duplicate samples that might be within your dataset. And that's the like TF-ID vector that I gave as an before, where you kind of create a vector for each one of examples within your data, then cross-reference if there's two high similarity scores, and then for each one of these similarity scores, what you would do is then filter out the score with the example with the lesser score, so to say, and then you would end up with a more diverse, high-quality data set once more. And this is also a thing that some intuitive approach that they've implemented within the data paper that I mentioned before for the Red Cross as well. And eventually what we managed to do was actually analyze all of the data, the Intel Orca pairs, filter out a lot of like gibberish examples, get the most representative examples by filtering more diverse examples, and actually managed to reduce the data set from 13,000 samples to only more or less 6,000. So that's roughly 54% reduction. And then fine-tuned the model like with that sample data set. And that actually resulted in the Distilabel models that we then and it was actually performing very well benchmarks. But once again, similar as we've seen with Notice, also very well from a human perspective. So more empirically tested, so to say. And that's actually a thing that we've also done yesterday or announced yesterday. And this is the example of the copy set from Argilla. I'm gonna use a similar approach for this example. We started off with an existing data set for multi-turn data and kind of skim through that using Argilla and actually monitoring and going over each example one by one manually, but through these filters that make it a lot easier to go over the data, and through like these semantic features that we have in Argilla, so that data exploration really becomes engaging, and that also you domain experts, but also AI engineers actually can work towards a high quality data set. And this is for us also a continuous process. So whenever you have your LLM actually running in production, you actually want to improve it and see if it still performs as well as you would expect to. And what we see is that there's ways to continuously fine-tune your models, and that's also, besides using just retrieval augmented generation or prompt engineering, there's also a lot to gain from actually having a high quality data set of your own and actually ensuring that it completely maps to your company. And that is the overview of how to clean our preference dataset with Argilla. So I recommend everyone to kind of try this out for the arbitrary preference dataset that you might have, and feel free to share with us or share on Hugging Face. And don't forget to kind of add this default reference to the created dataset. Are there any questions? Then I would like to thank everyone for coming. If there's feedback, feel free to send an email or reach out on Slack, and then hope to see everyone again next week or in sleep. And I wish everyone a good night, evening, morning.
Thank you, David. Bye-bye.
You're welcome. Yeah, thanks again, Jacobo, for joining also. Hope to see you guys in the meetup. So if you have a nice cool project, feel free to reach out.
Sure, will do. Cheers.
Bye-bye.